Look up at the night sky. Every single point of light you see is real. A sun, most of them bigger than ours, some of them dead for thousands of years before their last light even reached your eyes. We live on a small rock, spinning quietly around one ordinary star in one ordinary galaxy, among hundreds of billions of others. And the strange part is, the more we learn about the universe, the less small our questions about it become. In this video, we're going to travel outward, from our own solar system to galaxies to the edge of what we can even observe, and into the mysteries scientists still haven't solved. Everything here is based on real astronomy, but space is also genuinely, honestly strange. So let's begin. Let's start close to home. Our own solar system. At the center is the sun, a massive ball of burning gas so large that over 1 million Earths could fit inside it. It's been burning for about 4.5 billion years, converting hydrogen into helium through nuclear fusion, and it has enough fuel to keep going for roughly another 5 billion. Around it orbit 8 planets. The rocky ones close to the sun, Mercury, Venus, Earth, and Mars, and further out, the gas giants, Jupiter and Saturn, massive worlds made mostly of hydrogen and helium, with Jupiter alone being so big that more than 1,000 Earths could fit inside it. Then come the icy giants, Uranus and Neptune, cold, distant, and strange, with winds faster than anything on Earth. But the solar system doesn't just end at Neptune. Beyond it lies the Kuiper Belt, home to Pluto and thousands of icy objects. And even further out, almost unbelievably far, is the Oort cloud, a vast shell of icy debris thought to surround the entire solar system, possibly extending nearly a light year from the sun. It's so far away that some comets from this region take millions of years to complete a single orbit. Our solar system alone is almost too big to fully imagine. And it's just the beginning. Zoom out further, and our entire solar system becomes just one small part of something much larger. The Milky Way galaxy. The Milky Way contains somewhere between 100 and 400 billion stars arranged in a giant spiral shape roughly 100,000 light years across. A single light year, the distance light travels in 1 year, is about 9.5 trillion kilometers. So, just crossing our own galaxy at the speed of light would take 100,000 years. Our entire solar system orbits the center of the galaxy once every roughly 230 million years, meaning the last time we were in this exact position, dinosaurs hadn't even appeared on Earth yet. And the Milky Way is just one galaxy among an estimated hundreds of billions, possibly over 1 trillion, galaxies in the observable universe. Some are spiral like ours. Some are elliptical, smooth and rounded. Some are irregular, shaped by ancient collisions with other galaxies. In fact, our own galaxy is on a slow collision course with our neighbor, the Andromeda Galaxy, expected to merge with the Milky Way in about 4 to 5 billion years. It sounds catastrophic, but because stars are so far apart from each other, actual star-to-star collisions would be extremely rare. Mostly, 2 galaxies would quietly pass through and reshape each other. Now, let's talk about one of the strangest, most fascinating objects in the universe, black holes. A black hole forms when a massive star collapses in on itself after running out of fuel, crushing an enormous amount of mass into an incredibly small space. The gravity becomes so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. At the center of almost every large galaxy, including our own Milky Way, scientists believe there's a supermassive black hole. Ours is called Sagittarius A star, with a mass roughly 4 million times that of our Sun. In 2019, scientists captured the first ever direct image of a black hole's shadow in a galaxy called M87, a historic moment in astronomy, turning something once purely theoretical into something we could actually see. Black holes also bend space and time itself. Near a black hole, time actually passes more slowly compared to somewhere far away, an effect predicted by Einstein's theory of general relativity and confirmed by real experiments and observations. We still don't fully understand what happens at the very center of a black hole, a point called the singularity, where our current laws of physics simply stop making sense. It remains one of the biggest open questions in all of science. Here's something that might sound unbelievable. Everything we can see, every star, planet, and galaxy makes up only about 5% of the entire universe. The rest is made of 2 mysterious things scientists call dark matter and dark energy. Dark matter doesn't emit light, and we can't see it directly. But we know it exists because of its gravity. Galaxies spin in ways that shouldn't be possible unless something invisible is holding them together. Scientists estimate dark matter makes up about 27% of the universe. Dark energy is even stranger. It's believed to make up around 68% of everything that exists, and it's the mysterious force causing the universe's expansion to actually accelerate over time rather than slow down. To be clear, dark matter and dark energy are strongly supported by observational evidence, but what they actually are at a fundamental level remains unknown. It's one of the biggest unsolved mysteries in modern physics. For most of history, we could only guess whether planets existed around other stars. Today, we've confirmed the existence of more than 5,000 exoplanets, planets orbiting stars other than our Sun. And scientists estimate our galaxy alone could contain billions more. Some of these planets sit in what's called the habitable zone, the distance from their star where temperatures could allow liquid water to exist. That doesn't guarantee life, but it makes these worlds especially interesting places to study. We haven't found direct evidence of life beyond Earth yet, but missions like the James Webb Space Telescope are now capable of analyzing the atmospheres of distant exoplanets, searching for chemical signs that might hint at biological activity. It's one of the most active, exciting areas of research in modern astronomy, genuinely open and genuinely uncertain. Let's be clear about what's solid and what's still unknown. We're confident about the structure of our solar system, the existence and behavior of galaxies, the physics of black holes near their edges, and the presence of thousands of confirmed exoplanets. These are backed by decades of observation and evidence. What remains genuinely uncertain, the true nature of dark matter and dark energy, what happens inside a black hole's singularity, and whether life exists anywhere else in the universe. These aren't failures of science. They're the honest edges of what we currently understand, and some of the most active areas of research happening today. The universe is almost incomprehensibly large, so large that light from some galaxies has been traveling toward us for over 13 billion years, meaning when we look at them, we're literally looking into the ancient past. And yet, all of this, every star, every galaxy, every black hole, started from studying one small, curious question at a time. We haven't figured it all out. Not even close. But maybe that's exactly what makes looking up at the night sky still feel like something worth doing.